Yo. Good morning. What's up, Derek? Hope you had a wonderful weekend. Okay, so we're back at it, and hopefully we will finally be able to do some tessellation today after implementing the weather system and experimenting and stuff. So let's take a look at where we are at. So I want to pull up the snow, which we have below right now. So currently this is pretty much the state of our snow. Just a quad, not tessellated at all right now. The reason it looks like this weird is because we're trying some things with the topology or the indices, the order of the indices, because we want to tessellate this one in a very nice way. So let's pull up procedural snow, and then we can pull up weather effect, I think. Yeah, here we go. What we want to do is that we want our domain to be quad here when we subdivide. I just think it gives a little bit of a nicer subdivision. But if our tessellation shaders and domain shaders are implemented with the domain quad, the CPU needs to tell the GPU that that's the case. And in Unity, it's my understanding that we do something like this. So when we create a mesh and we set the indices of that mesh, so in what order we should iterate through the vertices to create triangles or quads, whatever. And then we can set the second argument here to be mesh topology quads, and that should be okay. The only problem is I've never worked with mesh topology quads except for some tiny experimentation here and there. I wonder how they want the indices to be made. So if we take a look at this, so when you work with triangles, which I'm actually starting to miss, but this will be a better result. So if you want to do a quad, you define 4 vertices, and then you have to define how the triangles are structured, like which vertices. So like a quad is 2 triangles, but these 2 triangles, which vertices creates one triangle and which vertices creates the other one, and in what order. And usually you want it clockwise. And I think my go-to is I usually go this one first and this, then this, which means that you get your first triangle that looks like this. And then I go, if I remember correctly, I usually go this one, this. So that means that the second triangle looks like this. And we can see here that they are clockwise. So my question now, I didn't find any information. Maybe I haven't searched thoroughly enough, but we're gonna do just that soon. Because when we have a quad, we don't want to split this one into 2 triangles. So when we define the indices, we want to define the indices and order for a quad. And initially I thought this would be the way to go, right? Or just like this then. Here you have your clockwise quad. This one gives buggy visuals. What we do now is this, I think, gives buggy visuals. The only one that works in game without that gives the best result so far is this one, if I remember correctly. The only problem with this one being that the selection outline in the scene view in Unity gives the wrong outline. And that bugs me, because that tells me that something is a little bit off with this quad. We were just about to get to the bottom of it, or try to get to the bottom of it, when I had to run last Friday. So hopefully we can get to the bottom of it today, quickly, and then we can start to experiment with the tessellation. And we already have some pretty nice tessellation. But then we can start to deform this tessellated plane instead, and we can start getting the slopes nice and even by doing quad flips. And yeah, I think it's gonna be a very interesting week. But this problem. So let's start by doing some Googling with this. Let's see if we can get to the bottom of it. So I want to do good morning, Harukanen. Hope you had a wonderful helg. I'm gonna do mesh topology quad unity, and let's see what we have. Why do I have a light mode here? Give me 1 sec, and let's see if I can. I should have dark. Oh well. Why is my Google search light now? Or has it just been so many days? I don't remember it always being light. Okay. Harukanen, guess it was alright. Hope you had a decent one as well. Yeah, I did. Thank you. And alright is still alright. The documentation in itself doesn't say that much. Mesh is made from quads. Each 4 indices in a mesh form a quadrangular face. Quadrangular face. Note that quad topology is emulated on many platforms. So it's more efficient to use, yes. Unless you really need quads, for example, if using direct. So this is exactly what we're using, and we really need it. Quadrangular, never heard of. First time seeing this word. Does this one imply vertex order? One. So this is the order for our quad that actually gives the best result as well. I wonder if this is the go-to order. Nah, not really. Well, and this is anti-clockwise. Procedurally create a mesh of quads Unity. Someone must have done this. Don't want to watch a video right now. We can look at this. Always good stuff here. Do we have quad? Oh, beautiful. Oh no. Triangle as well. Quad. One sec. Only triangles. I wonder. Create a quad mesh via script. So here they do it by triangles. They go 0 to 1. See here. They define them as... Okay, they define them as 0. Where do we have it there? 0, 1, 2, 3, and then they go 0 to 1. So 0 to 1, they go like that, and then they go 2, 3, 1. 2, what? Two, three, one. Oh. Okay, okay, because they do. Never mind. They do it like this. And then they go 0 to 1, 0 to 1. And then go 2, 3, 1. Like this. So we get this. And we get this. 0, 2, 1, 3. So I wonder if we wanna emulate this as well. But with quad, we don't have any quad example here. And let's try it. It's not that hard. So let's exit this one. And in our, when we do position here, How do we create it here? We create it by... We do X first. So I wonder... Harukanan, have you not manually created meshes before? I'm sure you have, like the terrain stuff. Yeah, we have, 100%. But I have never created one with mesh topology quads. That's the problem. It's a little bit weird how they want you to set the indices when you do mesh topology quad. It seems. You choose the way you want to traverse grid. Right now we're defining the, like, we're telling, so we generate a set of vertices and then we define the mesh topology basically. So how should we traverse these vertices to create stuff that are actually renderable? So triangles or quads. Triangles we can do. I can probably do it in my sleep, but the quads is weird. So I said at the beginning that this is how I usually do it. I like this order of things. So 4 vertices, then I define the indices 0, this one, this one, this one, and then this one, this one, this one. So when we were doing quads and we had 4 vertices, I thought I would just do it like this one. So that gives an issue. So what you want to order them as is this n, but that gives its own issue. It looks like you traverse 1 and 2 points twice. Yeah, we do. That's what you do. Like, we have 4 vertices and 2 triangles. Each triangle has 3 points, which means that some of the points are going to be reused, right? But that's how it is when you create topology. Harukanan. We just read it before you entered the chat. Note that quad topology is emulated on many platforms, so it's more efficient to use triangle mesh. Unless you really need quads. For example, this is what we want. Like when you tessellate a mesh that has a triangle or triangle topology, you don't get as nice tessellation. If you do it with quads, however, you always get a perfect subdivision. And that's what I'm after. I can show you what we have if we do it as good as we can so far. Let's just see if I can. So we want the n, so we want to go up 1. One sec, is it actually the n we want? Right now, this is the n we have. Harukaran, yeah, I see. That makes sense indeed. The tessellation would be a hell of a lot easier and nicer result. Hell yeah. Like, we got quad tessellation working last Friday. It's just one thing that bothers me, and I'm gonna show it. I'm gonna show it what it is. But like, the difference in triangle tessellation and quad tessellation was night and day. Like, quad tessellation, beautiful. But let's see here. So if we do it like at n now and it doesn't work, how did I do it then? So I guess we go, oh yeah, we probably did j times resolution I plus 1. Let's see here. Let's keep these parentheses. Maybe something like this. So bottom left, right, top left, top right. Let's see what this gives. The only thing that bothers me with the result we have so far is the selection outline in Unity scene view. And I can't find any information regarding that. Like, does the scene selection shader not work with procedurally generated quad meshes, or are our indices wrong? If this can finally finish render, we can probably show it if we don't crash. And then we put it up. Okay, this is wrong. Maybe. Yes, it is. Okay, let's go up to the right, and down. Here we have it. This is what I'm talking about. So right now we get a mesh that works perfectly-ish. Let's see, backface cull, let's go 0.5. It doesn't work perfectly, but you can see here that the selection is weird, but most of the other stuff we want works correct. So if we tessellate this one right now, it looks beautiful. Like, this tessellation, amazing. But what annoys me is this selection. So like, what's up with this selection here? This selection tells me that something is wrong with the topology, but I have no idea why or what. I don't know if we don't get backface culling, and still backface tolerance. And if we flip this one, Danny3, what's up? How long have you been using Unity 6? I migrated my project to Unity 6 at the beginning of this year, so just over a month right now. And right now I think it's pretty cool. All the things, or specifically with the render graph, I'm very impressed by. I like it a lot. Although I have been getting some weird crashes in Unity 6, and I haven't figured out if it's my bad code or something else. Harukanen, I need to read into the quad topology stuff in Unity. I wish Unity docs had a dark mode. So do I, 100% agree. And when it comes to reading into the quad topology stuff in Unity, I also need to do that. Unfortunately, it doesn't really exist that much information about it. So the whole enum mesh topology quads, this is the full documentation for this one. And then you have, like, I haven't been able to find that much. I mean, I don't think it's that useful unless you're using tessellation. So pretty much like the documentation points out here, and like you pointed out, Harukanen. But yeah, you have this little information as well. And it's a set triangles, and triangles always set the mesh to be composed of triangle faces. Use indices to create a mesh composed of lines or points. They don't even really mention quads here. Harukanen, yeah, well, for terrain it would be awesome. Fuck yeah, man. So if we can get this to work, it's gonna be beautiful. I wonder if that selection issue has to do with start position of the indice. It might very well be. I'm grabbing straws as well, so we're probably gonna have to brute force this. I can't seem to find that much information. And that's why I'm wondering, so if we take the Unity's official code for creating a quad via script, and see if we can deduce anything from this. If we can just transform exactly this into quads in some way, I don't know. Bruce, it feels like with one path you can add 1 point from 2 to 8 triangles. I just don't know how yet. It feels with one path you can add 1 point from 2 to 8 triangles. Not really sure I'm following. Then interesting but no game-changing bugs. Not that I've found yet. So except for my custom render features, the migration was pretty automatic. So no complaints there. It's just this, when we do GameView.repaint, when we start playing the game, it sometimes crashes. But once again, it could probably be because of something I do wrong, but I don't know. So I really want to get to the bottom of this. So Unity's official way to do it, or what they say, is see here, 0, 1, 2, 3. This is how they create the vertices, and then they do 0 to 1, 0 to 1, and then they do 2, 3, 1. So 2, 3, 1. Both of them ends at 1. Okay. Currently, when we create the vertices, we create them like 0, 1, 2, 3. I don't think we don't need to care about in what order we create the vertices. It's the indices that are the biggest problem. But this is how we create the vertices, right? We move... Or fuck is it? Nah, we create them like 0, 1, 2, 3. But everything we need to think about is that if we increment j, we move up. If we increment I, we move to the right. So right now, the current setup is we start at this one, and then we move up, and then we move to the right, and then we move down. So we create our quad like this, and if we create it like this, if my understanding is correct, that's when we get this weird stuff. And it also seems like we don't get any backface culling here. And if we take this one and we rotate it like this. Okay. Okay. So this is the backside. Okay. So what we're seeing here is we want this to be the front, but it's actually, thanks to how we set the indices, it's the backside. Okay. That can probably tell us something. Then great work, Robin. Please don't stop. Yeah, I don't... Thank you, first of all. I appreciate it. And I don't have any plans on stopping just yet. So, okay, what this tells me, I mean, our custom backface culling algorithm could probably, might have some issues with that, but I don't think that, because it worked with triangles. Let's just take a quick look at the implementation. Should backface cull, we do interpolate by linear, which is our implementation as well, but it shouldn't really matter. I don't think, no. Our normal, yeah, I'm a little bit worried about the normal though. It could be that we don't generate any normals just yet, but if we do, okay, let's try and do this then. Set in the z's, and then we do recalculate normals. Let's see if we get some proper backface culling. Bring it up. We get some weird stuff. Here we have it. 180. No back face cold because our tolerance is pretty high. If we go down to this, we don't get any. We don't get any anywhere here. Okay. Maybe recalculating the normals like this is the wrong way. So let's do vector 3 normals. And here we do normals. Like that. How many indices are you giving it there? We quad you need only 4 indices, not 6. Yeah, we're giving it 4. And I think we also created the correct size. I don't think that should matter that much. We can double check. Okay, so now we have this. But actually, like, okay, so it seems like we're getting it rendered from both sides, I would say. I have back-facing culling here. Oh, now it's getting back-face culled the right way, I think. 180, where do we have it? There we have it. So if we flip it 180 degrees, we can't see it from the backside. That's good. We get, let's see here, I think we get this culling because we have something wrong with the bounce. We're gonna focus on that one later on. Once we have fixed this. So I mean, it backface culls correctly. That's thanks to the normals. This selection. What we also tried last Friday was that we took a model, a mesh from Blender, a plane 8 here, and then we fixed it to we did, let's see here, maybe we need to try this. In the geometry here we did, it should be okay. We did keep quads. We have it here actually. Just to see, do we still get this selection issue with a quad mesh from Blender? It seemed to be working with that one. I don't know if all the setup was correct. But Harukan and quad meshes gets triangulated on import, I think. Yeah, I think so as well, but I think they don't if you have if you set keep quads as true, it keeps the quads. Which was what we tried, but I don't know if we might do that test again. I kind of wonder how it handles n-gons. That is a good question. Maybe we should try it. If we open up Blender now to create a quad plane to bring into here, why not? Let's add an n-gon as well, and let's see what kind of and how it works. The thing is, let's see. Let me do. Good morning, Geralt. Hope you had a wonderful weekend. My question is, I want to do terrain, procedural snow. I want to fix one thing here. I want to do tessellation amount. Let's change this one to a 0 and do that. Then where the snow at? We're gonna get to the snow soon. So even though we have a quad here, we send it down to the GPU as a quad, we do everything, we still, like, it still renders as a triangle, given the selection wire here. But let's do this. Let's open up Blender real quick. Hopefully, Danny, I won't disappoint today. I hopefully will get some very nice tessellated snow eventually. So here we have a plane. It's a quad. Let's scale it up a bit and do subdivide once. So now we have a plane that is 4 quads, and Harukanan, let's try some n-gons as well. So let's just do circle, but let's bring down the resolution a bit, so we can go with a, what is it, hexagon, and we bring this one up here, scale it up as well. And we add a face to it. So here we have one plane that is 4 quads. We haven't triangulated it. We have a hexagon with 1 face. Haven't triangulated it. And then we take this object, we export it. Let's see here. Let's put it in models. MISC. Yeah. And then let's call it test. Putting on the lab coat indeed. Test mesh. So now my question is here. We're going to go with selected objects. I'm going to do this transform. I'm just a little bit, do we have any triangulization setting here? Geometry, normals only, export subdivision, apply modifiers, loose edges, triangulate faces. This one is not ticked, so that's good. Ooh, this one I have never noticed before. It's a never-ending war with sRGB. As soon as you start doing things where you pack data into color channels, sRGB is always going to battle with you. We do some data packing into vertex colors here, so this one I need to untick in the future. But okay, the important things here are triangulate faces off. But before I export this, we're actually going to do one more thing. We're going to rename both of these. Test mesh and test mesh. Okay, there we go. And now we export it. Where do we have... Here we go. Test mesh, selected object, apply transform, and these are off. Okay. Beautiful. We jump in here. Let's see. And then we have our nice test mesh here. And what we do then is keep quads true, apply. And then we bring this one into the scene like that. And using the selection wire here, like it triangulates it. There's no way around it. But if we don't trust this one, like this is done, but we're hoping that the mesh itself is sent to the GPU as quads. How does it get sent in such a way that we get the correct selection outline? That's my biggest question. We can also do this. One sec. If we take our snow, I just have to double check so it's not our tessellation that screws up this, because it might very well be. So I'm just gonna pop on a MISC material. Let's go with this one maybe. Okay. This tells me a bit more. Okay, so the topology is fucked. Our tessellation shader, for some reason, manages to save it. Okay, so doing it like this is wrong. We need, when we give them, when we set the indices, we need to set them so that the triangles can be derived, I think. So we need some zigzag pattern. So so it's either, starting point is interesting as well, but we can either do it like this or we could do it like this. If we only have one starting point, how many ways can we do it? We can do it like this and this. Could we go? We don't want to go like this, do we? That would be extremely fucked. I think we tried these two. Harukanan, wonder if there is a way to see index number on the vertex. You could also make a custom editor script to display it's on the vertex, but I wonder if there is another way. That would be extremely handy in this case. So in the scene view, pretty much you could have numbers. Sounds like something that is not available. Unity mesh C vertex indices. Get indices. Probably have to rely on something like that. Yeah, worst case, that's something we're gonna have to do. But I'm wondering, like, so when we set the quad indices, if we need to set them in such a way, 2, 3, 1, what would that be? If we set it like this, then we get, this one is clockwise, this one is counterclockwise, but same here. I can't imagine, but what the fuck, I have nothing to lose, that they want us to set the indices like this. But if we do, I guess both of the triangles, it could be deduced that both triangles are I don't know. I'm losing it here, so let's try it. If we want to set it like this, it's pretty much, we do 0, add to both of these, then we just add to I, and then we just add to J. So something like this, but that would be crazy. I think. Yeah, that's the weird thing with the previous setup we had as well. The tessellation works with that one. The selection doesn't. And what happens if... Fuck, I don't remember us trying that. What happens... What if Unity still wants 6 indices even though we're working with quads? Does that make any sense? Does that make any sense at all? So I'm talking about... It doesn't it? We comment this one and do rain mesh patch mesh. Might as well. So do like this, and then we do 0, up, and then we do like this. Let's see what we have. It was up over on YouTube. Gonna have a hard time pronouncing that one, unfortunately. But you can, you say. Let's see. Nah, then we get this. Some half shit. Get the correct selection though, that's good, I reckon. But now, yeah, now it becomes that this point is twice. Yeah, this is wrong as well. We get a tessellation like this, it's not too bad. So let's see here, what do? We do, no, this one. J, that's 1. This one we have tried as well, I think. Is the other half flipped? No, in this case, what happens is that we try to create mesh topology quads. We give it 6 vertices. It only uses these 4, which means that we go... our last point is the same as this one, which means that we actually just gives it 3 points. It creates a triangle instead of a quad. And yeah, that's about it. So let's bring it up again. And yeah, this one yields this one, which works beautifully, except for the selection, right? So this is extremely nice. One sec, we're actually gonna try, let's see if we can do, look, we even have dynamic tessellation based on distance from the quad. And it all works. It's not backfaced cold here, but if we do this, we get backface culling. We don't get front face culling. 80. Beautiful. So I mean, everything works. It's just the selection. That is hella weird. I'm gonna try one more thing. So the best results we do get when we parse the vertices, like, let's take the exact we do. When we parse it like this, that's the best result. I wonder what kind of, like, if we can get the selection to work if we parse it. This is clockwise as well, so that's good. We can try and parse it like this as well, but then it's counterclockwise. And then we can also try to change the, like you said, Harukanen. Let's pick this straw and try to change the first point. So maybe we start up here and go like this instead. So this one best so far. I actually tried asking ChatGPT about this as well, like mesh topology quad procedurally generated in Unity 6, but it's still working on it. There really is not much information out there, to say the least. So let's brute force it like we have. So let's try this. So what we want to do then is we want to go to the right first, +1. Then we want to go up to the right, and then we just want to go up. Danny, me too, Cappy. Okay, Cappy. What's up, Cappy? This makes no sense, but I like to watch it. Appreciate it. Hopefully it will make more and more sense. So we start at bottom left, go to the right, go up, and then to the left. So we parse the quad, or we define the quad like this. Now the problem is that we're counterclockwise, but and now we have it like this. So the only difference here is that this selection issue is, instead of being here, it's here. Apart from that, we can tessellate it. Does it tessellate? Yeah, it's counterclockwise as well. So if we bring down backface, tolerance, we have it here. 80. Here we go. Here we have it. So yeah, this doesn't really give us anything else. I think Unity only processes triangles. Yeah, that's the weird thing. Like, the support for quads isn't that big, it seems. If we go to set indices, you can do set indices to set different mesh topologies, and you can define mesh topology quad. But then again, you only want to use this if you're doing tessellation. So But that's like, I wonder if the support for quads, procedurally generated quad-based meshes, isn't that great, and it's only a visual glitch with the selection. Like, that's what I'm starting to lean towards. I.e., if we set it up like this, everything works except for some editor support. But it should be triangles at the end, no matter what type it is. Like, of course, like always with computer graphics, basically, or this. But like, what we want to do is that in our shader, we have a tessellation shader. So we have a hull shader and we have a domain shader. And in HLSL, if we want to tessellate in a quad way, you can do this, domain quad, which means that we process this geometry as quads and not triangles, because we get much, much better tessellation if we do it like this. But to be able to rely on this hull shader and domain shader, this quad, hull and domain shader, we need to tell the GPU or whatever shader is in work to process this as quads. And that's what we do when we set indices mesh topology quads. So this is what we do here. We send down the information and we tell it to process it as quads. And like, once again, I can't understate this enough. It works apart from the weird selection issue in the Unity editor. So like, we also have a solution, so our terrain is usually rendered with a material that has a tessellation shader and a geometry shader. The thing is that we work with the geometry as triangles in that tessellation shader. But when tessellating using triangles, you get a very ugly pattern, which we don't want. And that's why we're experimenting with doing it with quad tessellation instead. The result is way more beautiful, except for the selection glitch. I hope that makes things clear, or clearer. Yeah, I think, like, you're entirely correct that, like, in most cases, like almost always you work with triangles, and that's the full pipeline. Maybe you start working with quads when you do it in Blender, but as soon as you export it and import it in Unity, it's triangles here on forward. And if you go with the vanilla graphic pipeline, so you don't inject any hull or domain or geometry shader or whatnot, it's always gonna be triangles until you get to the fragment shader. But in this specific case, like, this is the specific case that breaks it, because here we want to work with quads instead. And I get the feeling that since in 99.999, repeating of course, cases, you only work with triangles, Unity doesn't really have the best support for quad mesh topology, and that's why we're seeing the selection glitch. Have you tried pass vertices data directly? So we could do... you could do points here. So we do the same thing we do now, but we do mesh topology points. And then we redefine our snow here to work with points. I think that's possible if I remember correctly. But to answer your question, no, we have not tried this, and I'm a little bit afraid of doing it, because if we take a look at what happens when we do tessellation, so if we do tessellation, so we send down a quad to the GPU, and then we have tessellate it once, which means that we split this quad into 4 different quads, and then eventually triangles at the very end. But each vertex here holds data, right? It holds object position. We can check it here. It holds object position, normal in object space, tangent in object space, and UV. And when we generate new vertices, we need to properly interpolate these values. And that we get for free when we use Quad, basically. Or, yeah. Not through mesh class. Okay. That would mean that we would pretty much need to define our own graphical pipeline, and I think that's a bit too much. Programmer Jeff, what's up? Thank you for the follow, appreciate it. Let's see here. I'm just going to double check what my lovely ChatGPT says. We can bring it up on screen here. And let's see if this one has found something on internet that we don't. Bottom left, normals, triangles. They call it okay. They do 0, 1, 2, 3. So bottom left, bottom right, top left, top right. Really? So they do it like this. Didn't we try that one? One sec. Bottom left, bottom right, yeah. Top left, top right. Mm-hmm. Yeah, doing it in this order, I'm pretty sure we have tried it. So bottom left, bottom right, top left, so then we just need to do this, and then top right. Bottom left, bottom right, top left, top right. Okay, so let's see how replaceable I really am. Ooh, yeah. It's wrong. Unless, like still, I don't think we're looping wrong or nothing. Yeah, what I'm thinking about doing, we're gonna do, let's jump back to, where do we have this one? Harukan, I wonder if selector issues will get fixed when you run generate bounds. We can try it, so we're gonna do two different things. So what do we do here? We do this one. Bottom left, bottom left, bottom left, top right, bottom right. So this one gives the best result. Do the quad tessellation work? Don't think it is, because so far just passing triangles data. No, it works if we set up the indices like this. Let me show the best result we have so far. So the best result we have so far is this. Selection doesn't work, but tessellation does. Beautiful. Beautiful. So this is the best result we have. The only thing that irks me or sits wrong with me, the selection. Because this selection screams wrong topology. But this says right topology. It's facts. Okay, Harukanan, let's try. We're gonna do. Let's try mesh.recalculate bounds. See what we get. I think we will get a little bit of a better full object culling here. But if it would fix the selection, I would be very happy. Still the wrong, but now we get a little bit better culling, I would say. Optimized mesh might also fix that. The thing is that Unity's selection stuff is triangles. So yeah, that's what I'm starting to slowly but surely we're converging towards that. I'm confused as well. Slowly but surely, I'm converging towards the conclusion that Unity's selection way of doing selection assumes everything is triangles always, and that's why we're getting this issue. But there's still that little doubt in my mind that something is wrong. Harukanan might be a bug report on that checking. Oh, thank you, appreciate it. Hopefully it is. And look at this, this is so nice. We even get dynamic tessellation we should be getting. So the closer we are, the more we tessellate. That's great. But I want to try one last thing. I have if we change the initial index, let's say that we do this, but we do it counterclockwise. What does that give us? We tried it here actually. But let's say we try this one. Okay, last thing. And then we continue with the conclusion that Unity's visual selector doesn't work with quads. Right? I think that's fair. So we change the initial index and we do counterclockwise. So we do we start at the right one. We move on to top right, then we move to top left, and then we take bottom left. So bottom right, top right, left top, bottom left. Same result, but we now have it back faced colored. Or we have the faces inverted pretty much. Yep. Okay. It feels like I'm gonna have to sit down and do some proper real research with this to actually get to the real bottom of this. And Harukanan, if there doesn't exist a bug reported on this, I might very well do one. Maybe we should do this. To do actually, let's put it here. Notes. Get to the bottom of the index order for meshed topology quad by first researching, or by first searching. If nothing is found, create a new thread, and eventually bug report. Let's keep it like this. I hate when you get to this point, you are almost entirely sure that this is true, but there's still this little bit of doubt. But you just have to like conclude it and move on. So let's see here, resolution. Generate mesh, we have resolution 2 right now. Yes. So if we set this one to, we can set it to 4, which means that we will be getting 4 vertices. We will have something like 1, 2, 3, 4. So we will have, by default, we have 9 quads. And this is where the selection becomes. So now we will just repeat the selection issue we see, but we will repeat it for each quad. I'm going to show you what I mean. So we bring this one up, and now the selection looks like this. But then again, tessellation works. Now we can really see the dynamic tessellation. So for the original quads, closer to the camera, we tessellate them more. Further away, we tessellate them less. And this is, I love this. Look at this. Might need to update the tolerance a bit. But yeah. I find it weird that we do a full object cull here, but not this way. The bounds still not perfect. We're gonna draw the bounds as well. Can we do that? Weather effect, no. I mean, this is gonna be beautiful as snow. Like, look at this. So if we're running on this quad, we don't tessellate these. Pretty much not at all, actually. Like this. This one not tessellated at all. This one a tiny bit. This one more. This one even more. And this one the most. And we're also doing this. So we're going to deform this mesh like we did with the previous mesh we had. And when we deform it, we might want to do quad flips, align them with the gradient, so we get some smoother things. And that's also something we wouldn't be able to do with triangle tessellation. Not really. Not as good, at least. The selection. So what we're gonna do here is, I want to test one thing. We're gonna exit and we're gonna do, let's remove this, and we remove recalculate bounds here, because what I want to do is I want to set bounds myself like this, mesh render bounds. And then I want to do environment controller, weather handler. Yeah, let's do it here. Private void on Gizmos raw. On draw gizmos. And then I basically want to do weather effect. We can also do generate mesh. Public void. No, not void. Bounce. Get bounce. By default, I want to do return. Yeah. Bounce.empty. Do we have that one? No. New bounce. Transform. That's true. That is true. We don't want to do it like that. I would like to be able to we have bounce here. That's true. So let's play this again. I want to check what bounce we have for this snow object, because it looks a little bit weird. So let's take this one and bring it up. And do we have mesh renderer? Don't we have bounce for our mesh renderer? Ah, come on. Because what I'm seeing here there are a few related to quad drawing resulting in triangles, but nothing about selection or outline stuff. Okay. Maybe we should create one. The bounds for this one seems to be wrong. Okay, so let's do it like this then. Mesh renderer bounce. Not manual, I want bounce. Ah, the bounding box of the renderer in world space. very important. So when we do bounds, when we create a new bounds here, we want to do not vector 3.0, we want to do terrain patch dot transform dot position plus 0.5 times this. Now we should hopefully have the correct bounds. But then again, if we bring it upwards, yeah, we're gonna lose the bounds, but that's okay. I'm more important. Okay, and we cull it here. Yeah, we cull it right here. That's good. Okay, so when we get this culling here, the only thing we need to do for that one is we just need to tessellation view frustum tolerance. We just need to put this one. I thought we were just needing to put this one upwards a bit, but unfortunately that doesn't seem to be the case. Okay, so that's something we need to fix. But apart from, yeah, we culled them a little bit too early. But that's okay. So now we have way better full object culling, at least. And I want to check tessellation view frustum tolerance. View frustum, what do we call it? Tolerance, v position CS. Position CS. What if... need to restart. I just wonder if we put the upper bounds of tolerance to really, really high, do we still get this screwed up? Or this aggressive culling? Oh, it's this one. 3, if we put it at 4, it seems to... No, that's not enough. 5. 8. Still get a little bit. This is weird. The fuck? Really? That I don't like one bit. We're really gonna have these, need to have these high values, maybe. And this is where we cull the entire object, I reckon. Teen feels a bit high, honestly. Position CS. Vertex shader output. Yeah, we calculate the position CS the correct way. Vertex input, position OS, position clip space. Yeah, we do. But it's a float 4. I'm gonna have to look into this one. That might also be an issue with, let's bring this one down to here. Let's bring this one down to 0.5. Okay, 0.5 is way too much. 1. Yeah. 5. Let's put it at 15 for now. Although I wonder if we take a look at our procedural grass terrain material. Tessellation. Here we do view frustum cold tolerance constant as 1. And it works. Hmm. We're going to research that one as well, but let's see if we have So I wonder, is this... This is probably enough tessellation, I would reckon. But I like 2, 4, 8, 16. I like when it's the power of 2. So we're gonna end on... For now, we're gonna continue with weather effect. The snow mesh being 5 times 5 vertices, so 4 times 4 quads. And that's our default. And we do it like this. We set the UVs, we set the normals, we set the vertices, and then we set the snow. So this should probably be correct. So let's see what we're doing here then. Calculate snow vertices. Yeah, we don't do anything of this. So let's bring back this and see how our snow looks. Let's see if we crash Unity or not. Position center OS. Oh yeah, yes. Position center VS. Oh yeah. Okay. We have to fix this little issue first. But before we do that, I'm just gonna be right back, or AFK real quick. I need to grab myself a new cup of coffee. So be right back a couple of minutes. Okay, backstory about that. Let's see. So one problem we have here is that usually, so when we did this in the vertex shader previously, we got object space. Fuck, did we? I'm pretty sure we had. Yeah. So previously when we did this in the vertex shader, as opposed to the domain shader, we worked with position in object space. Right now we only have position in world space. But I don't know. So of course we could put we could send position object space onwards and test, like, interpolate that value as well, but it would be nice if we kept it to world space. So we're gonna have two big things we want to fix here in domain shader. So previously we worked with object space position, as I said. Now we have world space position, and the second problem being that, so what we do here is a little bit of a kernel, basically. So we have, we pretty much want to process 9 vertices at a time instead of 1. But the way we do that, we don't have any knowledge about neighboring vertices. So the way we do it is by pretty much recreating the neighboring vertices. When we had a static mesh previously without tessellation, we knew, or we sent down that information from the CPU, like this is the distance between vertices, and that made it extremely easy to recreate. So that's mesh grid delta. This time around we don't know that, and we have to handle this in a little bit of a different way, because we need this when we recalculate the normal. But so the question is, like, when we read the middle vertex, we need to get its 8 neighbors, and to get those we need to know about tessellation amount, and I just need to double check the fact that we always subdivide the same amount, so meaning that 1 quad turns to 4 quads, and then for the next tessellation the same happens. So a quad always becomes 4 quads and nothing else. If we can make sure that that's the case, then we know that for the amount of tessellation we have at this point currently, we have this distance between vertices. So yeah, those two problems, we want to solve that. Let's do the easiest thing first by double checking so that we always subdivide. We can do it like this, can't we? There we go. So what I want to check now is does our tessellation do it in steps of x to the power of 2 or 2 to the power of x? So here we have the original. This is the original quad. If we tessellate once, this quad becomes 4 quads. If we take a look at this quad now, if we tessellate once more, it becomes 4 quads. I want to do this. This quad becomes 4 quads. This quad becomes 4 quads, and it continues onwards like that, correct? So we're probably gonna have to send onwards something that tells us how many times we have subdivided it. Is this enough of a tessellation? We can probably go a little bit higher here, actually. I would say. We can start with this. So, and then I want to be able to debug this in a very good way. I don't want to sit and try and analyze lighting calculations to see if the normals are being generated correctly. So I wonder if we can do, or should we do that? But okay, if we send down, if we tessellate 0 times and then we send down the distance between vertices, and then we just divide that distance by how many times we have tessellated. So for instance, if we have a distance of 1 here, and we tessellate once, we know that 1 quad becomes 4 quads, so we divide it by 2. And here we divide it by 4. 1, 2, 3, 4. And yeah, we just divide it by the tessellation amount at all times. That should 100% give the correct. So we're still gonna have, where do we have it? Here. Mesh grid delta. So this is the world space distance between 2 vertices. And then down here we set tessellation amount. We return hull shader patch constant function output, which we take as input in domain, and it's in the domain we want to use it. So hull shader patch constant function output. Although I wonder. Hull shader patch. No. Okay, we get factors here. Oh, that's beautiful. Okay, never mind. We don't need to add something. So we actually have this information already. Naturally. So the input to our domain shader is both hull shader patch constant function output and hull shader control point output. And if we take a look at those two, we have, so it's this one and this one. And here we can see that we have edge test factor. We have 4 edges, So that's the 4 edges of the quad. And then inside we have I'm not entirely sure about this one, why we have inside 2. Could this be it actually? I want to try one thing here. I want this one to be 1 here. Could this be the selection issue? If we take a look at the quad, I might not fully understand this one just yet, so we might want to double check that. But if we take a look at the quad, we have, when we tell it how to subdivide, we have edge factors per edge, then we have inside 2. Okay, we have inside 2, I think, because we want to tessellate this like this, so we get 2 edges on the inside. Is that it? Output patch. Patch constant data. Want more information. How to create a hull shader. How to design a hull shader. And 2 additional factors tessellating the inside of the patch. Okay, that's okay. And given this test factor, so I guess we're going to continue with the assumption that these are all the same. I guess we can safely assume that since we set them ourselves here. So we just need to grab one of them and divide with that one. And we should be able to use this one. Yeah, it should be pretty straightforward, I reckon. We should just be able to do, let's uncomment this. And then we have position OS. First of all, we have position center OS. We don't have the center in object space anymore. We have it in world space. And then it's this one as well. Mesh grid delta. And I think this is where we want to do and here we want to divide it. Where do we have? We want to divide it with factors dot edge, and we're just going to pick 0 here. And that should be everything we need to do here to recreate world space. So now we need to be careful here. Position OS. Position world space. And when we define a snow vertex here, we're going to go with VS for both of these. Position VS, position original VS, VS. And that should be about it. The only thing we have left to do is to send in the proper mesh grid delta. So previously we had we used the terrain mesh. And it was we pretty much just took the terrain mesh, copied it, and used that as snow. This time around we generated it ourselves procedurally, and the mesh grid might not be the same. What's up, Cooler SK? Are we winning at water? Hell yeah. Okay, so mesh grid delta. We set this one in weather effect, I reckon. Set terrain properties in material, and here we set it. This time around, this one is wrong. Let's do it in a little bit of an ugly way right now and do let's keep mesh grid delta. Let's do it like this. Terrain weather effects, set terrain properties in material. Bool include mesh grid delta true. False, and then we set it ourselves. Mesh material dot set dot set float mesh grid delta, and then what we want to set it to. This one we're gonna do magic int, magic string. And we're gonna clean this up eventually. Okay, let's do it like this. Let's clean it up now. At least these two. Weather effect type is mesh dependent. Subdivision. Mathf how 2 to the power of subdivision. See, does this make sense? So if we have 0, we get 1. If we have 1, we get 2. If we do +1 here, we get... So if we set in 0, we don't subdivide it at all. So we get 2 to the power of 1. We get 2. So 2 vertices, 1 quad. If we set subdivision 1, subdivide it once, we get 2 here, to 2 to the power of 2, 4. Which is wrong. I think we want to do it like this. So if we send in 0, we get 2 to the power of 0, which is 1 plus 1, so we get 2 vertices, that's correct. If we subdivide it once, we get 2 to the power of 1, which is 2, which gives us 3. Yeah, I think that's correct. So then we take subdivision here. From to int. That gives us the correct here, and then here. Do we actually want to do... So if we subdivide once, I think this is the correct... let's try this. And then I want to jump back to this one. And So then if we do environment, weather, we do snow. Data, weather, snow. Dependence is subdivision, and we do, let's try it with 0, which means that we should only get 1 quad. Which we do. If we put it at 1, then we get 1. And so for instance, if I want, let's say that I want 16 times 16. I want to subdivide it 2 times more, right? Is that a bit overkill? Or that becomes 8 times 8, right? Subdivision 3. Let's bring the snow upwards. 8 times 8. Ah, beautiful. So right now we have this becomes 9. Because it's the number of vertices, but whatever. So 9, and then we do 9. So this is 8 terrain patch dimension minus divided by 8, and that's our mesh grid delta. And I think that's okay. So now let's try and add this back. See if we have any errors. Yes, we do. Get vertex position inputs. Ooh, yes. But we don't care about that. Instead, what we want to do is position center VS. Let's do position center VS is equal to, and here we do this place is bigger than 0.5. We return snow vertices. Actually, this one. We'll remove this. And position, it's this one we transform to clip space later on. Let's see what this yields. Position original OS. Do we still position original OS? Yeah. We want to change this one to VS as well. Unexpected token output. Yeah, we need to define this one. Because we don't... Oh, actually, we do. So why is it unexpected? Because we forgot this one. Okay, what do we have? Yeah, we don't have... let's put this one at 0. We don't show anything because we take this snow and we set this place. Fuck, it's 1. We don't get any displacement. I'm just gonna try and do this real quick. Here we go. So, what do we have here? Yes, we have something. Yeah, we have full displacement on the snow. It's now aligned to the underlying mesh, but we also get this weird culling here. I want this one to be 15. Now we don't. We just changed it for this one, so that's okay. And what happens now? We get a little bit of displacement, but it's kind of fucked. And I wonder if that's because we fixed the position here with factors edge. But UV, we do UV center, UV, this one should. Be interpolated, but then we do UV step, and this is where we fuck up. UV step also needs to take factors edge 0 into account. I reckon. Yeah. So UV step is much like mesh grid delta divided by factors edge. It's the UV step distance between neighboring vertices. Right now we just base it on terrain base data size, which I think is wrong as well. So UV step should be 1 divided by factors edge, I think. So let's try that. 1 divided by factors dot edge 0. Although it's always, yes. So by default it's 1. So for our full patch we have a UV, 1 UV step is 1 long, but then we divide it by factors edge and we multiply it by float 2 1 1. Okay, let's try this. Still don't see any proper deformation. It's interesting. But of course, we're gonna double check this. If we take a look at this one, of course we don't deform good enough just yet because we actually only have, we don't have that high of a resolution on our mesh. So let's see what happens if we bring up the tessellation amount. I'm a little bit worried that we get holes in the snow so we can see the beginning and end of each patch like this. That doesn't bode very well. But if we do it like this, we get something like this. That is pretty bad, isn't it? And if we bring this one down, yeah, it seems like we are we're not following the underlying data that good. The shading looks, the shadowing here though looks so much better than the previous result. But I'm wondering why we're getting these issues. Snow White. And I wonder why we don't get any lowered color as well. Okay, so a few things. Get terrain base data level bilinear and activity data level bilinear base sample level. This will just make it a little bit clearer what we deform and what we don't deform. And with 20, that should be good enough. Could it be... no. Ah, fuck. I want to change 20 and 10. Yeah. Get the feeling that first of all, this, don't like this at all. Tells me that something is a tiny bit wrong with UV offset. And this could probably be because of it as well. But let's see, where do we have it? Here we go. I want to double check. We look from above and we bring up the ground. Data is way... Get the feeling that we read from a minimized area, a way smaller area than we want. Do snow, yes, this we can do. Show, let's see here. Displace 0. And we show displace down 1. Yeah. Looks a bit too blocky for my taste. And the data we're actually reading is this one. It's a bit off. isn't it? No, actually it isn't. We're reading from the middle of the pixels. I want to try and see what happens if we do this. Let's crank up this one too. Hope it won't crash, but we're gonna quadruple it. So we'll probably take a little bit more time to start, but hopefully no crash. So now we make the underlying data way more high resolution like this. We still have this issue. Like, I don't care that much about the popping here, but when we get issues like this, that's what I don't like. The deformation of the snow here actually doesn't look too bad. A bit too blocky maybe. But if we were to take this one and do one here, how does it look then? I think the normals are getting calculated pretty damn good. But I need to fix this. Yo, what's up, Charco? So what we have here are... Okay. Okay, we're getting... I mean, the vertices are still at the exact same world position. They still get different Y offsets. It's weird. Way better performance right now, though. That's nice. So here, for instance, we get a mismatch because this one is just one or two vertices. This one is 5 vertices. And we... Ooh. Charco, how's it going? It's going pretty good, I would say. Trying to get this tessellation with the snow working. How about you? How's it going? Okay, so this question, ooh, I don't really know. I don't really know. Ooh, how do we want to handle these cases? We could probably do it with a secondary distance, I guess. No matter. And by secondary distance, so the distance from the camera decides how much we tessellate it. But if we're here, we tessellate it, but we don't, for all of these vertices here, we just use this and this one. So even though we tessellate it, or even though we subdivide it once more, we keep this one as if edge was one factor bigger, basically. Shark, I'm doing all right, just implementing a 3D character controller for interactable items. Nice. Because that would mean that for these edges, if we can minimize the distance we get, so for these, even though we have 5 vertices here, we just calculate the height of them as if they were 2. But does it exist a better way to do it? I think that's probably what we're gonna have to do. Yeah. Max distance. We don't even get any popping here. Looking beautiful. Not a too big fan of the edges currently, but that's okay. And look here as well. Where do we have it? This right here. So we get a few jagged shit here. We're gonna quad flip it and make it look much better. Same here. This can probably come real nice eventually. But okay, the biggest problem is definitely gonna be doing the syncing between subdivision patches. But I think we can manage that. And I would like it to work a little bit better with lower resolution terrain data. Here, if I don't know about, let's see. Oh, this fucking, I love seeing this. If we can just make the syncing between patches as well. Fucking great. Snow. Selection wire. And then we do get a very bluish color here, but I think that's because we have ambient multiplier at 0.5. I mean 0.5, 4, 3, 2. Maybe it affects it a bit too much anyway. Maybe that is where we want to land. Something like that. But okay. So I'm wondering. So this one is a perfect example. This square or this quad gets subdivided x times. This quad gets, or we can take this example instead. This quad gets subdivided x times. This quad gets subdivided x plus 1 time, which means that we displace, when we only displace 2 vertices for this one, we displace, 4 vertices on this one. Or 3, which means that we get this. And this one is even worse. Here we displace 2 vertices, and here we displace, 4 vertices maybe. So we just need to figure out, we need to identify where this is a problem. And when it is a problem, we want to subdivide this one less time. And I'm not talking, or we want to subdivide it as many times, but when we calculate the data, we want to move up in one resolution. So we want to base, so the UV step should be reduced. Or made bigger, actually. The UV step bigger, but what we divide with should be reduced. So basically, let's see what happens if we output. So in the domain shader, we want to do something similar to this, this, and this. And if we do that, like we want to make this. Yes, we need, yep, okay, I get it. So we don't want to base, we don't want to divide this with whatever we have in factors edges here. We want, but that might, no, it should be okay. We want to divide, we want to calculate this ourselves in the domain, because this is per quad, which means that a quad can be quite big, so parts of the quad might be very close, parts might be very far away, but all of them get the same output.edge values. So let's see. Let's just take this and this and put it do we have show activity height float? No, what I want to do is here float test scored 5. So in output here, before we output, I want to put this view vector. We have world space camera pos XYZ position VS. I'm gonna take the original one. So we calculate the view vector, we take the distance of it, and then we this, and we do output dot test is equal to t. And then in the fragment shader, I pretty much just want to do return input dot test. And I want to double check now. So this value that we return, is it the same at the edges between patches? Hmm. So if we take here, how does that look? That looks pretty damn good. Yeah, I think we're golden. How does it look here? Hard to see when it's displaced. So let's disable that. And bring this one minus 0.01. Still displaced. But I think it's roughly the same. Or exactly the same. So yeah, I think we can play around with this value. I'm a little bit worried, however, at this point here. Ah, that's true. So here. I think it will work. So let's try and do let's take all of this. Move it here. I want to take this one. Let's see what kind of result we get from this. Still have it. Can't really. It's a little bit. Nah, it's fucked. When we do it in the domain shader like this, this vertex and this vertex it's still a little bit of a difference between the distance. But not this big. Did I do something wrong here? Position center. One sec. Okay, we're getting the positions of the subdivided vertices here. So this one should be roughly equal to this one. Still feels like we are not taking this into account. But then again, I don't know if this is just a normal thing or tessellation amount. I don't think this will fix it, but let's double check. So, like, when we do the tessellation and check the distance from the camera, we do it on a way bigger area, so for the full quad. But then when we have tessellated and do it again, I was hoping that we were gonna do it on the tessellated. If we skip the round here, that's not the problem. Could be, but one sec. Oh, of course. Or could do is tessellation max distance times 0.8. Because I'm I get it. It's just we fixed the normals by doing this. So I think this is correct and will yield the correct result, but we still need to truncate UV center. That's what we need to do as well. We need to truncate this. By doing this and this, we truncate the UV step, but we don't truncate the UV center, which means that that one will still read from the correct one. Let's implement a... Do we have HLSL truncate? Trunk. That's not really what we want to do. Truncate float. Yo, what's up, Namida? Truncate float. To step. Or HLSL round float to step. Do we have... Ooh. Just return. Okay, but we should be able to do this mathematically. It's just that I'm wondering if I want to implement util math. I want to implement it here. So maybe we should. So if we implement float truncate, float f, float step. So for instance, if we send in if we send in 1.28 and 0.25, we want to round this one to 1.25. .42, 0.25, 1.5. So return f return round f divided by step times step. Is that correct? I don't know if truncate or round is the correct. 1.28 divided by 0.25, and then we round it, so we get 5 times 0.25. 1.25. 1.42 divided by 0.25. Here we get 6 times 0.25. I think that's what we want to do. Namida, why do you do the graphics for the game first and not the gameplay? I do gameplay and graphics in parallel because I just find it to be more fun to develop a game when it's looking nice. Hope that makes sense. And then also you get the nice side effect of it looking nice when you post stuff online, which tend to make people want to look more on the stuff. Yeah, I know it's not the usual way of doing stuff, but that's the way I enjoy the most. So what I want to do here is then we do UV step like this, and then we do UV center is equal to truncate UV center, and we want to truncate it based on 1.0 divided by tessellation amount. But. Yeah, that's right. Oh, shit. Yes, I know why. But this could probably lead to something good. So what we do here is we truncate a float, which means that we probably just truncate 1. So let's do util math, float 2, truncate, float f2, float step. Return float 2, truncate f2x step, and truncate f2y step, and return. So now we should use this one instead of single float one. Let's see what this yields. Redefinition. So why does it work in this case? Because we return the same. Seriously? Undeclared. Yeah. One sec, I just need to double check. Redefinition, okay. And that's why it didn't work. Shit. Truncate, truncate. Nice. Hopefully. We get something that looks good. I'm pretty sure it's something similar to this we want to do. But okay. Not really. Namida, does the density of the grid depend on the camera and not on the character's position? Yeah, it's based on the camera. Or the view transform, I think. It sorta seems to work here, doesn't it? Here it breaks. One sec. What I'm getting at is when we read the height value of this one. Oh. Mm. Right now, when we... okay, I get it. Yes, this is not the correct way to do it. When we read the height value of this one, we currently read it, we truncate it, so we read this value, and that gives us this. When we read this value, we actually want to interpolate it between the truncated value here and here. We can probably move down one. I wonder how that would look. Let's try and do this. UV center, let's keep UV center as it is. And then we do base data height, base sample level. This one we base on tessellation max amount. Tessellation max amount, but we don't do to the power of 2. The less time we tessellate, can we do it like that? Nah, that will probably yield. Maybe. So the less we tessellate, the more we downsample the height texture. Does that make sense? We just have to get this. So if tessellation max amount, so it gets this one if we're close to the camera. One. If we're far away from the camera, we do 0. Yeah, we pretty much want the other way around. Then this won't work. One sec, let's... Float sample level is equal to... I don't think we need to lerp tessellation max amount 0 t. see what this. So if we're close to the camera, we get 1 here. If we're far away, we get 0. Let's try this. So that would be if we're close to the camera, we get 1 here. So t is 1, which means that we get 0. We don't downsample it at all. And then we move. Okay. And we downsample the height texture more and more the further away we are. I think that makes sense. With some minor issue. Between patches is gonna... we have more issues here. Do we downsample it? Probably downsample it too much here. But still doesn't work. Let's do... Actually, it does work. We might just need to adjust it a tiny bit. If we check here... but... This one is a tiny bit closer to the camera than this one. So we're gonna have to, if this works, offset it a tiny bit as well. Although I still wonder if this will yield the correct result here. So if we were to do... .9, 0.8. Mm. Ah. Actually, yeah, if we do it like this, yeah, when we read from one downsampled here, we're actually being affected by this one as well, and it's lower. So yeah, this approach doesn't work. We're probably gonna have to wait this one, I reckon. Or if we get connected vertices, which we do, we can base the height on those. But that won't work. We might have a case where we have... So here we just have one edge goes to 2 edges, but we might have a case where we have one edge goes to 4 edges. And then we're screwed. Now we should be able to do... I'm a little bit worried about like we have to make sure that the way we displace it, the parameters we take into account, that they are fully available for when calculating neighboring heights as well, because so that we get our normals the correct way. So anything we do should be available and redoable in the calculate snow vertex method. The problem so when we truncated it, the problem then is that we truncate it to either this or this, which would work in this case, but we actually want to truncate it to halfway between those two. Which we can probably fix. If we truncate it, round down, truncate it, round up, then we do that in the y direction as well, and then we interpolate it to 0.5. Truncated round down, up. That could probably work. So I'm talking about... Let's try it real quick. What did we do? We did... calculate tessellation amount like this. And then we truncated on 1 divided by tessellation amount. But then we're gonna have to read the values. Wonder if there exists a better way. Because we would have to do it in here. we would need to sample this one twice. Both of these twice. Hmm. Actually, we would need to read this one twice as well. That's pretty much what we're gonna have to do, I think. So what it basically becomes is so if we have one that is subdivided like this, and we have this one, basically what we want to do, we're gonna have to read it 4 times per. That sucks, but maybe we can use it for other stuff then as well. Because basically what we're gonna have to do is that if it's far away from the camera, or if it's within that specific bound, what we do then is we recalculate it as this. So we take this one and we truncated it in X and Y, which in this case would probably be here. So it's pretty much about recreating this quad right here and then interpolating the position to here. So we pretty much need to recalculate previous tessellation state. This would also work with if we have this, and then recalculate the previous. But we can probably simplify it a bit, I reckon. Yes, we can. We only care about this fact. We only care about this fact when u is equal to 0.0 or 1.0. Nah, that's not true. But we only care about that fact when u is equal to, or u or v is equal to the truncated value. But then again, it should be... Yo, what's up, Vintrix? Dropping in right at the end here because I gotta run soon. Oh, I love this kind of problem. I think we'll definitely be able to solve it. Gonna take... We could probably solve it now, but in a unusable kind of way. We just need to find a usable kind of way. And with unusable, I mean it's gonna wreck either performance or the normal calculations we do. Oops. But yeah, it's all about recreating a upsampled, downsampled version of the mesh-ish and interpolate the height value instead of specifically calculate the height value. But yes, so that's what we're gonna do next time. Unfortunately, I think my schedule won't allow me to stream tomorrow or on Wednesday, but I will do some longer streams on Thursday and Friday, as it looks right now. Because I gotta run now. I think it was some nice progress today. Extended my knowledge quite a bit. And yeah, so see you Thursday. Thanks for watching, everybody, and have a great rest of the day. Peace.